Hello everyone. I welcome you all for a brief video presentation on the topic memory management. A warm welcome to everyone. My name is Bharath M. I belong to the third semester of Computer Science Engineering Artificial Intelligence Department at Sri Venkateswara College of Engineering. Here we will be discussing a video presentation on the topic memory management belonging to the subject operating systems. The course code given is BCS304. Let us move on to the presentation. Memory management. What is memory management? Let us look at its definition. Memory management is a critical function of operating systems responsible for managing computer memory resources. Key tasks of memory management is that it involves allocation, deallocation, and organization of memory to ensure efficient use by processes. What are the goals of memory management? The primary goals are to provide a uniform view of memory to processes, protect memory contents, and maximize memory utilization. Now let us look at what are the challenges of memory management. Memory management must address issues like fragmentation, allocation efficiency, and ensuring processes do not interfere with each other's memory. This was about memory management. Now, let us look at what are the different types of memory. There are five different types of memory which we are going to discuss now. The first one is the physical memory. Main memory, which is the random access memory. This stores active data and instructions, volatile, divided into pages or frames. Virtual memory uses disk space to extend physical memory. This one provides a uniform memory to model to processes. Cache memory is a high-speed memory between CPU and main memory. This is also used to store frequently accessed data. What is secondary storage, um, which is a type of memory? Non-volatile storage for long-term data and programs. This is called as secondary storage. Example, HDDs and SSDs. Another one type of memory is registers. High-speed storage inside the CPU is seen, stores data and the instructions are being processed. These were about the five different types of memory. Let us move on to the next slide, which is on memory allocation strategies. First one is contiguous allocation. This one allocates contiguous blocks of memory to processes, simple but can lead to fragmentation. Non-contiguous allocation allows memory to be scattered across different locations. This reduces fragmentation. Paging divides physical and virtual memory into fixed size blocks. This reduces fragmentation. Segmentation divides the logical address space into segments, allows for flexible memory allocation. Combined paging and segmentation uses a combination of paging and segmentation for efficient memory management. These are the different types of memory allocation strategies. Let us go on to the next slide, which is memory management unit. What are the functions of memory management unit? The main function is it translates virtual addresses into physical addresses. This implements virtual memory. TLB, which is translation look aside buffer, caches address translations, speeding up address translation. Address translation process. Memory management unit translates virtual addresses using the page table, accesses the page table in memory if translation is not in the translation look aside buffer, which is known as TLB. Memory protection. Memory management unit enforces memory protection, preventing unauthorized access to memory. Our role in virtual memory is memory management unit allows processes to use more memory than physically available by swapping data between RAM and disk. Let us go to the next slide, which is on memory allocation methods. First fit, this allocates the first free block of memory that is large enough to fit the process. Best fit is it allocates the smallest free block of memory that is large enough to fit the process. Worst fit is it allocates the largest free block of memory, leaving the largest leftover fragment. And the buddy system, this one allocates memory in powers of 2, thereby reducing fragmentation, but this can lead to internal fragmentation. The last method of memory allocation is slab allocation. This slab allocation divides memory into slabs for different object sizes, reducing fragmentation for specific types of objects. These were the different types of memory allocation methods which we saw now. Let us go to the next one, which is on memory fragmentation. What is memory fragmentation? Fragmentation is the phenomenon where memory becomes divided into small unusable fragments. This is called as fragmentation. What are the different types of fragmentation? The fragmentation can be internal or external, means which is unused memory within allocated blocks. These kind of fragmentation, these are the two types of fragmentation which is seen. What is the impact of memory fragmentation? Fragmentation can reduce memory efficiency and increase the allocation time. Mitigation of fragmentation is defragmentation techniques can be used to reduce fragmentation and optimize memory usage. This is about memory fragmentation. Next, let us see about memory paging. The definition is paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. What is the process of memory paging? Physical memory is divided into fixed size blocks called pages, and virtual memory is divided into blocks called page frames. The benefits of memory paging is paging reduces fragmentation and allows for more flexible memory allocation. The implementation of memory paging, operating systems use page tables to map virtual addresses to physical addresses. Page replacement. When a page is not in memory, a page replacement algorithm is used to determine which page to evict. This is all about memory paging. Now here, let us go to the next slide, which is about page replacement algorithms. What are the different types of the page replacement algorithms? First, let us look at FIFO, which is an acronym abbreviated as first in, first out. What this algorithm does is, this evicts the oldest page in memory. The next is about least recently used, which is LRU. This evicts the least recently used page in memory. LFU is least frequently used. This evicts the least frequently used page in memory. MFU is most frequently used, evicts the most frequently used page in memory. And the last type which we will look today about page replacement algorithms is about random replacement. Random replacement selects a random page in memory for eviction. Randomly, a page is evicted during runtime. And these were the 5 different types of page replacement algorithms. Let us now look at the next slide. Memory segmentation. The definition of memory segmentation is segmentation divides the logical address space of a process into segments. What are segments? Segments are common segments include code, data, stack, and heap. What are the benefits of memory segmentation? Segmentation allows for more flexible memory allocation and management. Address translation is that segmentation requires a segment table for address translation. Segmentation fault. Accessing memory outside the bounds of a segment results in a segmentation fault. This is about memory segmentation. Memory protection. Purpose of memory protection is memory protection prevents the processes from accessing memory that they are not authorized to access. Implementation. Memory protection is enforced by the MMU, which is the Memory Management Unit, which uses protection bits in page tables. Protection levels is memory protection can be at different levels such as read only, write only, and execute only. Preventing segmentation faults. Proper memory protection can prevent segmentation faults and improve system stability. Virtual memory. Memory protection is essential for implementing virtual memory and ensuring processes do not interfere with each other's memory. This was about memory protection. Next, let us look at memory mapping. What is memory mapping? It's defined as memory mapping is the process of mapping virtual addresses to physical addresses. The role of memory mapping is it allows processes to access physical memory through virtual addresses. Translation is memory mapping is performed by the MMU using the page table. Memory mapping efficiency. Memory mapping improves memory access efficiency by providing a uniform memory model. Protection. Memory mapping also enforces memory protection to prevent unauthorized access. This is about memory mapping. Next, let us look at memory allocation policies. First, it is about global versus local allocation. Global allocation allocates memory from a global pool while local allocation allocates memory from a process-specific pool. Fixed versus variable allocation. Fixed allocation allocates a fixed size block of memory, while variable allocation allows for dynamic resizing of memory. Static versus dynamic allocation. Static allocation allocates memory at compile time, while dynamic allocation allocates memory at runtime. These are the memory allocation policies. Next, let us look at memory management techniques. Swapping is seen here. Swapping moves entire processes between main memory and disk to free up memory. Compaction rearranges memory to reduce fragmentation and makes space for larger contiguous blocks. Segmentation with paging. This combines the benefits of segmentation and paging for efficient memory management. Memory pool. This allocates memory from a pool of pre-allocated memory blocks, reducing overhead. These are the different types of memory management techniques. Now, let us look at what is memory fragmentation. Fragmentation is defined as the phenomenon where memory becomes divided into small unusable fragments. Types of fragmentation can be internal or external, that is, unused memory within block allocated or unused memory between allocated blocks. Impact is fragmentation can reduce memory efficiency and increase allocation time. Mitigation is defragmentation techniques can be used to reduce fragmentation and optimize memory usage. This is about memory fragmentation. What is memory fragmentation? Fragmentation is the phenomenon where memory becomes divided into small unusable fragments. What are the different types of memory fragmentation? Fragmentation can be internal, unused memory within allocated blocks, or external, that is, unused memory between allocated blocks. What is the impact of memory fragmentation? The main impact of memory fragmentation is that it can reduce memory efficiency and increase the allocation time. Mitigation is defragmentation techniques can be used to reduce fragmentation and optimize memory usage. This is about memory fragmentation. Now let us move on to the next slide. Memory paging. The definition of memory paging. Paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. Processes, physical processes divided into fixed size blocks called pages, and virtual memory is divided into blocks called page frames. Operating systems use page tables to map virtual addresses to physical addresses. Paging reduces fragmentation and allows for more flexible memory allocation. Page replacement. When a page is not in memory, a page replacement algorithm is used to determine which page to evict. The next is page replacement algorithm. This is same as we saw a few minutes back in the video. FIFO, which is first in, first out, LRU, which is least recently used, LFU, which is least frequently used, MFU, which is most frequently used, and another is random replacement. Memory segmentation, as we saw a couple of slides back, which is same as the given topic. Memory protection. The purpose is memory protection prevents processes from accessing memory that they are not authorized to access. Preventing segmentation fault. Proper memory protection can prevent segmentation fault and improve system stability. This is about memory protection. Next one is Memory Management Unit, or MMU, which we saw a couple of slides before. And let us conclude this video with a recap. Memory management is essential for efficient and reliable operation of operating systems. The key points which we saw is it involves allocation, deallocation, and organization of memory to ensure optimal use. What are the challenges is memory management must address issues like fragmentation, allocation efficiency, and memory protection. The future trends of memory management is as computer systems evolve, memory management techniques will continue to evolve to meet the demands of modern applications. Here we conclude this video. Thank you all for being a part of the journey. See you soon in the next video. Thank you.